incline plane example 4. Stacy, who has a mass of 45 kilograms, starts down a slide that is inclined at an angle of 47 degrees. Assuming that there is no friction, how fast will she be traveling after 2.5 seconds? So this is a different question altogether. It does involve an inclined plane, but ultimately this is a kinematics question. We're looking for her final velocity. Okay, we're being asked how fast she'll be traveling after a time of 2.5 seconds. So we're looking for our final velocity. We have a time of 2.5 seconds, and we know she starts down a slide, so she's going to start with an initial velocity of 0. And if we think about this, what are we going to be able to calculate? Well, displacement's going to be a challenge to calculate because we don't know how high the slide is. We don't have any distance measurements. But we can calculate the acceleration that she will have going down the incline. So to be able to answer this question, we need to have our acceleration. So let's get started calculating that acceleration. We're going to draw this. Here's our horizontal. We have our slide, and we've got our blob Stacy on the slide, and she has a weight, and that's how we're used to calculating this, thinking of these as forces. But what I want you to do is recognize that we can treat any vector quantity exactly the same way as we treat force. So since we're not looking for her force down the incline, we're looking for her acceleration down the incline. Instead of working with the weight, we're going to work with acceleration. So we know she has an acceleration due to gravity straight down of 9.81 meters per second squared. What we're looking to calculate is her acceleration down the incline. What is that acceleration? And that's going to be the acceleration that's parallel to the surface of the slide, or parallel to the inclined plane. So we'll just drop this here like so. We know the angle is 47 degrees, and so we can calculate this acceleration by taking g, the acceleration due to gravity, and multiplying it again by the sine of 47 degrees. And let's do that calculation. And we get an acceleration parallel to the plane of 7.176 meters per second squared. And so I've rounded this to 4 values, or 4 significant digits. So we now have her acceleration. So let's just cross that question mark out, and we have 7.176 meters per second squared. Now let's calculate that final velocity. So we have final velocity, time, initial velocity, and acceleration. That leads us to our acceleration is equal to Vf minus Vi divided by t. So we know our acceleration is 7.176 meters per second squared, and we know our final velocity is 0, so we can recognize that we just have our initial velocity is 0, so we have just the final velocity divided by 2.5 seconds. So we're going to multiply both sides of the equation by 2.5 seconds, and that will give us her final velocity. So it cancels here, and we get a final velocity for Stacy of 17.9, or to 2 significant digits, 18 meters per second.